Tape residue is the enemy, whether you're labeling leftovers or, building airplanes. But in aviation, it's less about sticky globs in the fridge and more about high-stakes chemistry warfare. Here's the problem. Modern passenger jets love to mix titanium with carbon fiber epoxy, like a fancy sandwich. But when you actually try to glue these two together, things get messy fast. The glue creeps, peels, or just gives up when the plane rattles. Why? Titanium is sleek, and carbon fiber is a bit, stubborn. Instead of bonding, they're like two surfaces coated with Teflon and trust issues. The old-school fix, scrub, sand, add adhesive, just isn't enough for your average airborne stress test. Superglues and prayers only go so far. Enter the science fiction part, lasers. Researchers, led by Davide Morello, Jenna Silvio, and Claudio Leone, took a high-precision laser to the titanium surface. Not to slice and dice, but to scribble microscopic grooves and bumps, like a tattoo artist for metal. These textures are actually smaller than a hair, so no, you can't feel them unless you're a dust mite with good vibes. But here's the clever bit. While the laser scribbles, it also fattens up the titanium's natural oxide layer. This means the glue, an epoxy resin, finally has somewhere to settle in. Imagine swapping out a smooth skating rink for a field full of tiny dovetail joints. Instead of the glue skating uselessly, it locks in like concrete poured over rebar. Vibrations, temperature swings. Suddenly, the bond is as stubborn as your uncle clinging to his vintage CD collection. In tests, these laser-treated joints held up dramatically better. Less creep, stronger bonds, and a jet that doesn't rely on hope and duct tape. Why does this matter? Passenger jets are stitched together from thousands of these joints. Stronger, lighter bonds mean safer planes, better fuel economy, and more room for those tiny pretzels. The detail worth slowing down on is the bottleneck. This idea is instantly visual, but the paper matters because the researchers are not just showing a cool object. They are asking whether the weakest part of the system can be redesigned. That is usually where the real science is hiding. Not in the shiny final demo, but in the annoying constraint that kept breaking the design before. Tape residue versus PhD-level laser treatment. Only one wins at 35,000 feet. Do you think we'll be zapping all our stuff to make it stick better soon? Or will someone just invent a smarter tape?